Hello everyone and welcome back to the garage. This is part 4 of the 1978 Williams Phoenix pinball machine restoration series. In this video we're going to fix all the remaining problems with this machine. We're going to get the drop targets all nice and working, make them look good. We're going to fix the 2 broken solenoids, the left pop bumper and left slingshot, and we're going to install the new soundboard so that this machine will have sound again. So by the end of this video, Phoenix will be a 100% working pinball machine. So let's get started. All right, so this is the original soundboard for the Phoenix. And as I explained earlier, I am just unable to find the problem on this board. It seems like it's some elusive thing. For now, we're going to install the new soundboard that I got for this machine. And here it is. This is the Co-Out Enterprises Williams System 3 and 4 soundboard. So this will work in any Williams System 3 and 4 pinball machine. And this board is noticeably a lot higher quality than the original board. It's thicker, so it doesn't bend as easy. That is something I noticed on the original soundboard. It bent quite easily. This board uses mostly all new parts, except for the 6802, the 6821, and I believe maybe the EEPROM as well, I'm not sure. This EEPROM was custom made for a Phoenix pinball machine, so this board should work. It came with a volume knob that inserts into this little connector right here. So this will be the volume potentiometer for the machine. So this board will be the new soundboard for the Phoenix. So let's go ahead and install this and we'll see if sound works on this thing now. All right, the new soundboard is installed right in the spot where the old one goes, and it fits just like it was the original board. So now that we have this new board in, let's go ahead and turn on the machine and see if sound works now. Ah, did you hear that? That's how it's supposed to work. The hum comes up for a second and then goes away. That's what it's supposed to do. So I can tell you, just by that alone, the sound in this machine is now working. And on this board, we actually have 3 LEDs on it for each of the voltage rails. So it makes troubleshooting on that board much easier in case you have a missing voltage rail. So that's another addition that this soundboard has. So I'm going to go ahead and push the start button and let's see if we hear sound. And yes, we do. So sound is working now. But I am curious, on this new board, it has switches. It has a push button for the diagnostic button like on the original board. And on the dip switches here, one of the dip switches controls whether or not it has the Williams synthesized sounds or if it makes tones that kind of sound like a really old solid state machine. And those 2 switches are present on the original soundboard too. This is the diagnostic button and this is the toggle switch to toggle it from synthesized sounds to tones. And the reason that I didn't use the diagnostic button on the original soundboard is because for 2 pinball machines, Disco Fever and Phoenix, on the original soundboard, the diagnostic button doesn't do anything. So it is unused in those 2 machines. But I'm curious if on the soundboard that we have now, the diagnostic button will do something, because I think that all comes down to the EEPROM and how it's connected, because the soundboard is not different between Phoenix and the other pinball machines that use the diagnostic button that actually have it in a working state. So the EEPROM on this board could be different. So I'm going to push the button and we'll see if we hear sound. And we don't. So I would assume that the EEPROM used in this board is identical to the one used in the original board. So what I'm going to do is start the game up again. And we can see that the volume pot is working. I want to push on one of the switches and see if it's in synthesized sounds mode or tones mode. It's in synthesized sounds mode. So I'm going to push on the outlane switch and listen to the sound that it makes. So that's one of the synthesized sounds. Now if I go ahead and flip the toggle switch to the tones mode, now if I roll down the outlane, it makes a little tone. And so for each of the point values, the 10, 100, and 1,000 points, it will make different tone pitches. So for example, you can see it's a different tone. But if I go ahead and flip this dip switch back, now it makes the synthesized sounds again. So we have a working soundboard in this machine now. So now what I want to do is go behind the cabinet and I want to put this into diagnostic mode so we can run the sound test and just see if all the sounds are working. So once this number gets to number 9, it will start making sounds. And there we go. That was all the sounds that occur during the sound test. So now we'll go back into game over mode. There we go. And so yeah, we have working sound now. So that is another of the major problems fixed on the Phoenix. So the next thing we're going to do in the Phoenix is drop targets and drop target stickers. And as you can see right here, I already put one of my 2 new drop targets in, and I put one of the new stickers on it. As you can see, it looks quite a bit better than, say, for example, these targets. You can see how faded they are. This sticker is a little bit different from the original, so if you look at the one on this side, ignore the part that it's fading, but as you can see, the bird decal is a little bit higher, and then I think they just made it that way so that you could actually see the whole thing when it's up. As you can see on the original, the bottom part of it is almost underneath the play field, and so whoever made these stickers wanted to raise that up a little bit, and so I think that looks better. Maybe it doesn't have quite as much detail around the edges as the originals do. You can see the edge black lines are a little bit more pronounced on the originals, but I would rather have good-looking drop target stickers than faded ones. And this drop target needs to be replaced anyway because it is broken on the bottom. And unlike the old target that was here, I don't have the piece that I can just super glue back onto it. So that's why I wanted to replace both of these drop targets, is because both of them were broken, but this one absolutely needs a new drop target. So I'm gonna go under the playfield and show you how to reinstall a drop target. So this machine, I believe, uses the first generation of Williams drop targets, and it's actually good that it does because they are the easiest to repair. So what you can do on these is you don't have to remove the entire drop target assembly. You can get away with doing it by just removing the coil stop and a little spring that's down here, and I'll show you how to do that. So there are 2 screws right here, and that will remove the coil stop. So that will actually take out the coil when you remove these 2 screws, because the coil stop and then this other metal part up here is what holds the coil in place for the drop targets to reset. So if we go ahead and remove these 2 screws, the coil will free itself. Oh, and I should mention on the back, those 2 screws, they screw into a little metal bracket on the back. So once you take out these 2 screws, the bracket's just gonna fall out. So once I start loosening up this screw, this bracket, yep, there it is right there, it just fell down. And there we go, there's that little bracket. It just goes sideways just like that, and that is what the 2 screws screw into. So now the coil stop is free, but what you wanna do before you remove it is you wanna push the drop target down if it's not already, and there's a little spring in the middle of the coil stop. It goes from the drop target to the coil stop. So what you want to do is make sure the coil stop is still in its original position, and take a pair of pliers and just remove that spring from the coil stop. And there we go, now it's out. So now the coil stop is completely free. Go ahead and just remove it entirely. Well, that's not exactly what I wanted to happen, but yeah, the drop target is free, and the coil stop, if I can get it out, there we go. And the actual part of the coil is free as well, so you can remove those if you want to, just so you have more space. So that's all the disassembly you need to do. And normally the drop target wouldn't fall out like that, I don't think, but this one's broken on the bottom. Oh crap, the switch is busted. So here's that drop target, and it is broken right here. There should be a little piece that kind of sticks out that way. It's supposed to be a little L shape, and that's why they call these the L-shaped Williams drop targets. But I'm looking at the switch on this now, This switch is almost about ready to break, so I'm gonna have to bend that a little bit and hope that it doesn't break when I do that, because I don't have any spare drop target switches I can use. And right here you can see what a good non-broken drop target looks like. You can see there's that little bit that sticks out, so it kind of forms an L shape. So that's why when that drop target reset, it would push up too far. It would stick way farther up out of the playfield than it should. So that drop target needed to be replaced. And as I said, the one that was right here, it broke off too, but I actually had the piece. This is the old one right here. So I was able to glue it back on, but I wanted to replace it just because it had already broken on me once. And so I didn't really want it to break on me again. So this is the new one that we're gonna put in place of the broken drop target. As you can see, we have the L shape, we have the new sticker on it, and it is identical to an original drop target. So it makes a perfect replacement. So let's go ahead and get this installed. So in the original drop target, you can see there are two screws that hold the switch assembly on, and then there's a screw on this side that holds that spring in place. So you have to transfer these to the new drop target. And so once you get all this transferred, installing it is kind of fiddly because you kind of have to do everything at once. So what you need to do first is put the drop target back in its track, but you also want to make sure that the spring here goes through the hole right here in the mounting assembly for the coil. So you can kind of just bend the spring out a little bit and get it in there first before you put the drop target in. So it needs to come out like this. And so now what you can do is put the coil back up inside the other piece of metal so it's in its normal position right there, and hold the drop target right where it's at without the spring going out from where it's at right now. Take the coil stop, and then so what you can do is take the coil stop and put the spring through it. So now the spring is in it, so the drop target cannot be removed now. But this is where it gets kind of fiddly, because now I have to put the actual coil rod, shaft, or whatever it's called back in. And so I need to put the drop target back into the reset position, so that's right there. So now I can take this part of it. You kind of have to have the coil removed for this. So when you get it into this point, when you have the spring reinserted back into the coil stop and you have the target reset, before you screw in the coil stop and everything else, remove the coil again, take it out from here, because now you have the spring on, so now you don't have to worry about the drop target. Put the little shaft of the coil back in, stick the metal piece through the hole, and then put the coil back like that. And so now the coil is back in, and so now you can go and get that little metal bracket, put it back on, put those two screws in, and you're good to go. And so what I like to do is put the screws in the holes of the metal piece first so that the coil will stay, and then you can kind of put the bracket up behind the screws and start screwing the screws into the bracket. So at this point, what you can do is look behind here and check that the switches on the drop target are riding against the little PCB that's back there. So you can go ahead and push it down and just make sure that when it resets and when it scores, that the switches are riding against the PCB, and they are. So this drop target will work when I turn the game on. And the new drop target is installed right here, and it looks good. So now if I go ahead and push it down, as you can see, it scores. And if I go down one of the lanes that resets that target, it resets properly. So that drop target is now fully working. So to do the rest of the drop target stickers on the Phoenix, we have two more drop target assemblies, one here and one here. And so we're gonna have to take these apart in the same way that we took apart the two in the center. So there are 5 screws right here that hold the combined coil stop assembly in place. So once you remove that, then you can remove on the other side the bracket right there that those screw into, and then you'll be able to get the drop targets out. But what you want to do with these, since the actual metal pieces on the bottoms of the coils are different, as you can see on the two in the center, they just have a little piece that goes inside the hole there, and on these we just have big metal squares. What you want to do is also remove these 5 screws, and that will remove this bracket so that you can just remove this entire assembly, including the shaft of the coil. You can just take it right out, and so that will make taking out the drop targets much easier. And these drop target assemblies are actually much easier to work with because the only thing that you need to remove is the metal bracket. You don't actually have to remove the coils on this one. You do have to remove the bottom bracket down here though with the 5 screws like I mentioned. But what you can do now is, since the only thing keeping the drop targets in now is the spring, you can just go ahead and push the drop target down, and then the spring is just going to come right off of where it is on the coil, and so you can just pull the drop target right out. So it's very nice. You can see how dirty and faded the stickers are on these. So I definitely have to replace those. I already removed 2 of the drop targets, so that was number 3, and this is the last one. We'll go ahead and pull it out. And there it is. Very dirty. So I'll go ahead and take off the drop target stickers on those targets, and all it's going to take is just a heat gun and a plastic spudger, and those stickers should come off no problem. So I'll show you what those look like after we have new stickers on them. And here we go. That was a relatively easy job. The old stickers came off really easy with a heat gun, so these are what the new stickers look like. They look just like the old ones, but they're not faded. So now the 2 new middle ones look just like the side ones. So those drop targets are now fully restored. So at this point, we are very close to having this pinball machine fully working. The only issues that I have to solve now are, I just have to adjust some of the playfield switches and clean some of them up because some of them are a little dodgy still, like the in lanes up at the top. Sometimes they might score twice when the ball rolls down them, and other times the actual switch assembly might get a little bit stuck. Like you can see number 3 is kind of halfway stuck, and then there it pushed back all the way out. I already did that to the 3 pop bumpers because it took some serious force from the ball when it hit this to make the bumper actually work. And now that they're adjusted, it only takes a tiny little bit and then the bumper goes down. So I have to do some playfield switch adjustment. But the only other major problem this machine has now is the left slingshot and the left pop bumper are not working. And when I turned this machine on for the first time and I reviewed the footage, I noticed that they were working, but then when I ran the solenoid test on the MPU board for the first time, those 2 solenoids did not work, and at that point when I ran the solenoid test, I had said I smelled something burning. So obviously something fried to make those 2 solenoids not work. Now what I've already done to kind of test and see what's going on is I had the playfield open and I tested the resistance on the 2 coils for these solenoids, and I also tested the diodes that are mounted on the coils, and the coils are good and the diodes are good. So that tells me that the problem is not with the 2 solenoids themselves, nor is it the switches, because I know the switches are okay on these 2. It is going to be a driver board problem. So if you look in the user manual for this game, not the schematic, but the actual manual, on page 27, it outlines all of the solenoids as well as all of the wires that are connected to them, but it also shows what are called the special solenoids. And it just so happens that the left jet bumper and the left kicker, that's what it calls the slingshots, are part of the special solenoids. So we have to look for that section on the driver board, because on the driver board, the solenoids and special solenoids are driven from different places. So down here on the bottom left, you can see the solenoids 1 through 16 get driven by these power transistors right here. So these are the regular solenoids. But up here in this little area, these additional 6 transistors, those are for the special solenoids. And the only other sections on this board that deal with special solenoids is this little section right here with these 2 ICs. As you can see, that is the section that drives special solenoids 1 through 6. And these are the special solenoid switch inputs, which are controlled by these 2 ICs. And then we have some resistors and capacitors up there. So this should be a very easy repair to do because we only have to deal with this tiny little section of the board up here. So we should be able to track down pretty easily what went wrong on the driver board in terms of special solenoids. So let's go take a look at it. So on the driver board itself, it is these 6 transistors that drive the special solenoids. And I assume these little transistors that are right above are the pre-driver transistors for those solenoid transistors. But when I was poking around this board, I noticed that this transistor, one of the legs broke off of it, and it broke off right at the base of the transistor. So I looked at the manual, and this specific transistor and the components that are around it are unused in this game. So that transistor being broken actually doesn't affect any of the solenoids because that specific solenoid is not used. And I did discover how the special solenoids in this game were actually wired. So if you have a Phoenix and you're trying to diagnose your special solenoids, I'll show you how they're wired and which transistor controls which special solenoid. So as you can see, each power transistor is labeled 1 through 6. They're kind of out of order, but you can see down the bottom corner 1, 2, 3, 4, 5, 6. Well, those numbers are in sequential order to what is shown in the manual here. So you can see we have 17 through 22, and number 22 is not used. So that means only 5 of the transistors on the driver board are actually driving something. So number 17 is driven by transistor 1. 18 is driven by transistor 2, and so on. It goes in sequential order. So for the left jet bumper, we need to look at transistor 1, and for the left kicker, we need to look at transistor 4. So the ones that we're going to look at are 1, the top left, and 4, the bottom right. And so what I think is happening is either the main driver transistor has failed or the pre-driver has failed. And I checked these transistors when I was first taking this board out of the machine, and it seemed that they were all good. So I'm suspecting the pre-drivers, which are these little transistors right above them. So I went ahead and ordered a set of those transistors, and they're already here. So we can take out the driver board and take out those transistors and see if they're actually good. Okay, so here's the driver board again, and I was kind of messing with this transistor. It basically just broke right off. So yeah, that's another reason I think that these pre-driver transistors might be the problem, because I was kind of wiggling them just a little bit and they kind of seem like they're a little weak. So maybe we have an open connection right at the base of the transistor or something. And I noticed that these two up here on the top, you won't be able to see it, but each leg on the transistor is black in a certain area. So it's almost like these things have gotten burning hot before. So I'm willing to bet that this transistor and this transistor are bad. And so that's why the special solenoids aren't working. So let's go ahead and do some transistor checking. All right, so I'm gonna go ahead and check the main driver transistors again, just so I know for a fact they're working okay. And this is gonna be done in circuit, so it's not gonna be the most accurate test, but we should be able to tell if they're good just by doing this quick check here. So between base and emitter, in one direction we should have nothing, in the other direction we should have between 0.4 and 0.9 volts. Well, maybe in this case it's going to be a little bit different because of the fact that it's in circuit. So if we see something that looks a little weird like that, just ignore it. There we go, 0.7. And just for sanity check, I'm going to see if this one is doing the same thing. So here we have 0.9, and if we turn it around, we also have 0.7. I'm assuming that the main driver transistors are okay because all the rest of the special solenoids are working, the other 3 that are a part of this game. So I don't think we have issues with the main drivers, even though when you have the leads in 2 different directions, they do that. And then between base and collector, which are these 2 pins, one direction should be nothing. Okay, here we have nothing. The other direction, we should see that voltage drop, and we do. So the other transistors, the lamp transistors, which are down here, they were kind of doing the same thing. I think if I test between, it's right there, we have 0.6, and if we turn it around, I guess we don't have a voltage. Oh yeah, we do. Okay. Yep, the lamp ones do the same thing, so that's not an issue. That's just due to the fact that it's in circuit. circuit. If I were to pull the drivers out and test them, it would probably actually have nothing in direction, unlike what it's doing now. So, okay, now we know. So this direction is where we should have the voltage drop, so 0.8. I'm doing base and emitter right here, 0.9, 0.9, and 0.8. So it looks like all these are good. And now base and collector, I must be yep, 0.6, 6, 6, 0.6, 0.6, and 0.6. Okay, so the main drivers are working good. So let's check the pre-drivers. So the pre-drivers for the special solenoids are also NPN transistors. All right, so let's test transistor 5 just so we can see what a good transistor looks like in circuit. So between base and emitter, we have our voltage drop of 0.6 volts. And ideally, if we were to turn this around, there should be nothing, but because it's in circuit, we get an erroneous reading, so that's okay. Between base and collector, 0.7 volts, that's normal. And if we swap the leads, we also get a voltage drop, but again, that's probably due to circuit. So that's what a good one looks like. Let's test transistor 1, which is this one, pre-driver. So right there, we have a 0.6 voltage drop here, 1.2. So that's like what we were seeing before. Here, 0.6 and 0.7. So it's identical to this one, which is odd because this transistor 1 is the left jet bumper. So you'd think that that one might be bad, but maybe it isn't. Let's go and test number 4, which is here. This is pre-driver 4. I just want to see what the 0.6, 1.2, 6. I'm just trying to see if I see anything that looks wrong. And so far when I'm testing these, every one looks exactly the same. So pre-drivers, oh, this one's different. 1.8 volts voltage drop. Which one is this? This is number 4. Oh, this is number 4. Oh, I was testing the wrong one. So this one's testing a little bit different. Well, what I'm gonna do now is I'm gonna pull that broken transistor out of circuit and just replace it. Even though it's not used in this board, I would like to replace it with one that actually works and not one that is just broken. So I put the driver board back into the machine because now I want to do some deep testing to figure out exactly what the problem is with the two solenoids, the left bumper and the left slingshot. So, things that I have tried. I've tried cutting the diode off of the coil on this left slingshot so it was out of circuit, and I tested it, the diode is good. And I know the coil is good too, because something else I tried is what you can do is you can hook a clip lead onto the metal tab of the transistor and short it to ground, and that will make the solenoid fire. So I'll go ahead and show that. I know this is going to be a little bit far away, but what I'm going to do is I'm going to take a clip lead, put it on the metal tab of special solenoid transistor 1, which is for the left pop bumper. And I'm going to take a clip lead and put it on there, and I'm going to short it against ground, which can be this screw right here. I'm going to start the game and watch the left pop bumper as I do this. As you can see, there it went. The left pop bumper is firing. And if I go ahead and do the same thing with transistor 4, which is the one on the bottom right, that is the one that controls the left slingshot. I'll go ahead and get that in view. I'm going to short that transistor to ground, watch the left slingshot. There it goes. So that tells me we do not have a problem with the coils. The coils are good. We don't have a problem with any of the switches. It is purely a driver board problem. Now, the special solenoids in these Williams games, they can either be controlled by the CPU directly, which is how all the other solenoids are controlled, or by the switch that controls it inside the playfield. So for example, if I go ahead and hit the switch that activates the right slingshot, that actually wasn't the CPU doing that. That was part of the special solenoid circuitry doing it. And that's the whole reason why they made the special solenoid switches, is because they felt like the CPU wasn't able to control certain switches fast enough. And so they wanted some of the switches to be like instantly activated as soon as they were hit, like the slingshots and the bumpers. But the CPU can directly control these solenoids as well. For example, the solenoid test, when it's going through and doing all the solenoids, including the special solenoids, that is the CPU controlling them because there aren't any switches getting hit. So because the switches don't activate, the solenoids don't activate with the switches, and they don't activate when the computer tries to control them, that tells me we have a problem in the circuit of the special solenoid itself, and that is located on the driver board. And it's actually a pretty simple circuit. I was looking into it, so a little bit of help from the oscilloscope should track the problem right down. So let's go ahead and take a look at the circuit. So how this works is switch solenoid 1 trigger. That is the playfield switch for solenoid 1, which is the left pop bumper. And so when the ball hits it, it will trigger this switch and it will send a pulse through here, and it's going to go through IC6, IC9, and then through these transistors back to the switch triggered solenoid 1 drive, and then that will trigger the solenoid. The first thing we have to look at is the blinking circuit. Now, that comes out of these two ICs, IC7 and IC9. And so on pin 10 of IC9, which is a 7402, the output should be low. And I think the blinking circuit in this game is working because all that does is make it so that the solenoids don't fire when they're not supposed to. So for example, if I was to reach down and turn on the machine, if the blinking circuit wasn't working, then right when the machine comes on, all of the solenoids would fire. So that circuit is just preventing the solenoids from firing until the system is fully booted up. So we know that's working because the solenoids don't fire when the machine is turned on. So we have to continue past the blinking circuit. So if we keep going down, the first thing we get to is this chip right here, IC9 7402. So how that works is when the solenoid is off, when the switch solenoid 1 trigger is not being hit, the input going through pin 3 of the 7402 will be low, and then the input going to pin 2, I think this is pin 2, is high. Now, if you look at the function table for a 7402, the output has to be high in order for the solenoid to fire, and so it requires both inputs to be low. And so when the solenoid is off, you can see one input is high and the other input is low. So that means the resulting output would also be low. And farther in the circuit, you can also see that the output of the 2N4401 pre-driver transistor is low, and then the output of the main driver transistor is also low. But if we look at it with the solenoid on, so that would be switch solenoid 1 trigger is being pressed, so one of the playfield switches is being pressed. Then when it gets to here, both inputs into the 7402 are low, so the resulting output is high. And then the output coming out of the pre-driver is also high, and that makes it so that the solenoid will actually fire. But these special solenoids can also be controlled by the computer inside the system. So when it gets triggered by the playfield switch, it goes from 2J13 pin 5 over here into pin 2 of this 7408. But if the computer controls it, it's going to come from here and go into pin 1 of the 7408. So that is how the control for the solenoids, the special solenoids, works. And as you can see here, we have solenoid 1 trigger and drive, solenoid 2, and it'll go all the way up to 6 because there are 6 special solenoids. Now the other one that we're having trouble with is solenoid 4. So this is the playfield switch wire that goes into pin 5 of 7408. Is it the same chip? Yes. So it's going in the same chip, the 7408, and then the computer control is going into pin 4. So let's go ahead and take the oscilloscope and check the circuit for solenoid 1 and solenoid 4. And we'll compare it to see if it matches what is shown here for the solenoid being off and the solenoid being on. And then we'll also take a look at the 7402 and see if this function table matches what the chip is actually doing. Okay, well, I tried to get all of this on camera without my head being in the way, but that seemed to be impossible. So I have the scope sitting on the playfield, and I'm just going to put illustrations up on the screen to show you what I am probing. So what I'm gonna do is hook the ground lead of the scope to one of the screws holding in the driver board, because that is ground. And we are going to look at pin 2 of the 7408 chip, because that is the very first thing that the playfield switch connects to. So if I were to take a multimeter and measure continuity between the pop bumper playfield switch and pin 2 of the 7408, we would get continuity. So let's go ahead and see what pin 2 of the 7408 reads. All right, so here is pin 2, and it is high, so that is correct. So if I engage the playfield switch, that should go low, and it does. So you can see when I hold the switch down, it's low, and I let go, it goes back up to high. So that is working correctly. So when the playfield switch is off, the output of the 7408, pin 3, should be high. So if we test the pin directly next to the one I was just testing, this should also be high, and it is. There we go. But it looks like it's only like 2.8 volts. There's pin 2, so that's 5 volts. Pin 3 has only got 2.8 volts, but that should also be high when the solenoid is off. When the solenoid is on, pin 3 should go low. And it goes lower, so it goes from 2.8 down to 1.8. So it's doing something, but it's not shorting it directly to ground. And so that might mean that the 7408 is the problem. And the way to figure that out is to test one of the working playfield solenoids, one of the special solenoids. Goes right to ground. So part of me is wondering if the 7408 is having problems, because I checked the transistors on the driver board. Pre-drivers are good and the main drivers are good. So it's obviously something before the pre-driver, and we saw that little anomaly on first solenoid. It didn't go down to ground. I wonder what would happen if I shorted that pin to ground. If I went and took pin 3 and shorted it to ground. I'm gonna do that real quick. So my theory as to this is, because we saw pin 3 not go to ground when I push down on the left bumper switch, if I short pin 3 to ground, let's see if the solenoid fires. Ah, there it is. The left bumper fired when I did that. So the problem is the output of the 7408 is not going to ground. So what I just did is I shorted this pin right here, number 3, to ground. And so when the solenoid is on, that is what it looks like. You can see it's low when the solenoid is on, so that means it goes down to ground. But you know what that means, right? If this goes to ground and the solenoid fires, that means the outputs for the 7402 is going high, and the output for the 2N4401 pre-driver is going high. And so that is making the solenoid fire. So the problem that we have, because the computer is not able to control it and the playfield switch is not working, we have a problem with this 7408 chip right there. So that chip will need to get replaced. Now, looking at solenoid 4, it is going through that exact same chip. So we can also test that one by shorting pin 5 to ground. That is the one that comes directly from the switch. So because that solenoid is not working, that's going to be the left slingshot. Sure, it still doesn't work. It does not. So if I short pin 5 on that same chip to ground, it's going to do nothing. I already know that. So let's count 1, 2, 3, 4, 5. It's doing nothing. And if I go ahead and short the output of that switch to ground, so that is going to be pin 6 on the 7408. And so if I do this and the left slingshot fires, then the problem is the 7408 with that solenoid as well. So I'm going to go ahead and short pin 6 to ground. Ah, nothing's happening. So we might have a different problem with that one. It might be a different chip, because I just shorted that to ground and it did nothing. Okay, what I really should do is take a look at the input for solenoid 4. So that is going to be pin 5. So let's take a look at pin 5 and see if that is high, because it should be high. And it is high. All right, I have the probe clipped on to pin 5 of the 7408. So if I go ahead and push the left slingshot switch, the scope should go low. and it does. Okay, so that's good. I just wanted to see if that was working, and it is. So here's what we just did for solenoid 4. I checked the switch by checking the input into the 7408 pin 5, and when I push the switch, it goes from high to low. So that is working, but I also shorted pin 6 to ground like I did for solenoid 1 when I shorted pin 3 to ground, and that did not fire the solenoid. So obviously there's a problem further along. So what should be happening with solenoid 4 is that the inputs into the 7402 should be high and low like that, and then the resulting output is low. But then when the solenoid is on, both of them are low, and so the output of the 7402 goes high. So we need to take a look at the output of the specific 7408 for solenoid 4. So that's this one right here. So pin 6, and it's the same chip. So pin 6 on the 7408 should be high when the solenoid is off, but when it's on, that pin should be low. Now, I shorted that pin to ground, so I made that pin go low, but nothing happened. So what I need to do now is I need to make this low again, and then I need to make 10 go high. Pin 10 on the 7402, that needs to go high, because as you can see right now, the output of the 7402 is low with the playfield solenoid off, but with it on, it goes high. So I need to kind of do some manipulation to the circuit here. So I'll go ahead and see if I can make that thing fire. So we're going to take a look at pin 6 of the 7408, and it should be high right now. And it's high, I saw it. So this is going to be very fiddly, because I have to reach in here, tap it on pin 6, and hit the switch with my other hand, see if it goes low. It does not go low. So we do have a problem with the 7408 there as well, because that should go low when the switch gets pressed. But because it's not going low, the solenoid's not firing. But as you saw, when I shorted pin 6 and made it low, the solenoid still didn't fire. So for these solenoids, we can kind of begin by tracing back. So the first thing we'll test is the main driver transistor. So when the solenoid is off, the input to that is low. But when it's on, the input is high. So let's just measure that real quick and see what it is. So first we'll look at the main driver transistor. So I'm going to hook directly onto the metal tab of the transistor because that is the base, and that is what I just showed you in the manual. So according to the internet, when I put my scope on the metal tab of the transistor, it should go high. That's really high. Okay, I'm gonna have to adjust my voltage per division. There we go. So that's getting the solenoid voltage directly. Okay, so let me take a look at something. The 7402 that comes directly after the 7408 for solenoid 4, the output of that is pin 10, and with the solenoid off, that should be low. So I just want to see what that looks like right now. And it is low, so that's good. So what we did is we shorted that pin to ground, and that didn't make anything work. But with that pin shorted to ground, I want to look and see if the output of the 7402 goes from low to high, because that will rule out if the 7402 is actually working. So right now it's low. So if I go ahead and I short the 7408 to ground, so it's gonna be pin 6, the 7402 pin here should go high. It does go high, look at that, 4.8 volts. So it's not the 7402. right, I think I have found the problem with the driver board that is preventing the left slingshot from working. So I was doing some more testing inside the machine, and the circuit works just fine up until we get to the main driver transistor here. We can get 5 volts into the pre-driver transistor, and we get 4.4 volts out of it. That seems a little bit low, but that should be enough for it to be interpreted as a high signal. And so we get the 4.4 volts into this transistor, but then nothing happens. So I used my meter and I checked resistance across each of the 6 transistors. And between the collector and the emitter, each one of the transistors measured resistance, except for this one that drives the left slingshot. It was open. So we have an open connection inside the driver transistor for the left slingshot. So there we go, we found the second problem. So this driver board, we have a bad 7408 chip right here, and we have a bad driver transistor for the left slingshot solenoid. So I'm gonna go ahead and replace those. All right, the driver board's now back in the machine, new 7408 installed right there, and a new driver transistor here. So let's go ahead and turn this game on and see if everything is working now. And it booted into diagnostic mode because I have the batteries removed. So I'm gonna get it out of diagnostic mode. There we go, back in game over. Everything looks like it's working still. I'm gonna put this thing in its solenoid test mode, and we'll see if the solenoids work. So that's back into diagnostics. Displays, lamps, solenoids. So we'll let those run and we'll see if the left bumper and left slingshots work. There's the left bumper, and there's the left slingshot. So that was it. That was the last problem that we needed to solve on the Phoenix. So now this machine is 100% working. So now I have this thing in the switch test, and so now if I push down on the switch for the left bumper, it works. And if I hit the left slingshot, there it is. So that was it. We had a bad 7408 chip and a bad tip 120 transistor. Well, now that the Phoenix is completely fixed and operational once again, let's go over what all was wrong with this machine. This thing's been left for dead since the 80s. What all failed? Well, first thing, we had battery leakage out of the battery holder, so that had to get removed and replaced with a new one. Then, we got the game working. The lamps had a problem. This transistor here was shorted completely, so I replaced that, and I replaced all the other lamp column transistors for preventative maintenance. I decided to upgrade these resistors from the original 3 watts to a 5 watt variety, just so they could better handle the current draw and heat that goes through them. And it's a good thing I did that because 3 of these resistors were bad. And then there were 2 pre-driver transistors for the lamp columns that were bad. This one and this one were bad, so I replaced them all. And so that got the lamps all working again. And then we also had solenoid problems, and we just figured out that it was due to this 7408 being bad and this tip 120 driver transistor being bad. So those got replaced, and now the left bumper and left slingshot solenoids work just fine. And then when I first put the board back into this machine after taking it out the first time, the 40-pin interconnect broke, so I had to replace that. So those were all the failures on the driver board, and so now this board is now 100% working. The MPU board didn't have a problem. The power supply didn't have a problem. And then we had the sound issues. This game didn't have working sound, so I tried to fix the original soundboard and couldn't really find the fault, so I bought a brand new aftermarket soundboard to go in its place. One day I will take a look at the original soundboard again and try to fix it, but for now I'm going to leave this board in here because it works and it's a much higher quality board than the original. And then the drop targets in this game also had issues. These ones wouldn't reset, so I adjusted the switch on the drop target that wasn't adjusted right, and so that's working. These 2 drop targets weren't working. This one had a broken diode and a broken switch on the back, and this one was rubbing on the back of this rubber like crazy, so I just adjusted the whole assembly so the target faced more forward, and now that problem is fixed. These drop targets were fine. These four didn't have any issues. Each one has new stickers on it now, so they all look nice. And the coin door switches also had problems. Both of these switches were out of adjustment, so if you put a quarter in them, they would not close, and so the machine wouldn't know that you put a coin in, and it wouldn't rack up a credit. So both of these switches have been fixed. I fixed the coin mechanisms so that they were adjusted correctly for a quarter, so now those are working. These set of wires, these were actually taped with electrical tape kind of up here. These are for if you want to put in a third mechanism in the middle, so that's what these are for. I just kind of leave them right there. So now the only things I have left to do to this machine are wax the play field, clean up the glass, clean up the lockdown bar, clean up the back glass, and just put all that stuff back in. And I'll also go ahead and clean up the cabinet as well, because as you can see in some spots, it's quite dirty. There's like these black marks where there shouldn't be black marks. The legs on this machine need to be sanded and repainted, because as you can see, this one in particular is quite rusty, and all the legs on this are rusty and dirty in places. The feet need to be replaced. The leg levelers, I have new ones of those. And that's something that I'm gonna do off camera, just because it's not really a major thing that needs to be fixed right this second. Maybe I'll put a picture of what it looks like in my community post on my channel or something. But yeah, legs just need to be cleaned up, repainted, new leg levelers, and then that will look good. So that's all it needs now. Just some little things that need to be done before I can put the glass on and the back glass. And then this machine will be ready to rock and roll. So, this completes the Williams Phoenix Restoration Series. Phoenix is now 100% working, all its problems have been fixed, and this machine is now ready for its second life. I'm going to include some gameplay footage of this game so that you can see this machine in action after it's been restored. So if you want to watch that, continue watching to the very end. But that is all for the Williams Phoenix Restoration Series. Thank you for watching, and I will see you in my next video. All right, before we start the gameplay of this machine, I wanted to give you the opportunity to see what this machine looks like with the correct shutter speed applied. So I'm using a different camera app so I can get it so that the displays won't roll on the screen and that the lights will actually show correctly. So this is what the machine looks like. You can see the player 1 display is alternating between high score and the current score. The player 1 light is pulsing, and when the player 1 display displays the high score, the highest score light comes on. So that is what that actually looks like. And as you can see, the other 3 displays are working as well, including the master display. The game over and ball and play lights are on, and those 2 will be lit together when you first turn the game on, and the player 1 light is on. So with these settings, I can give you accurate gameplay, and you will actually see the lights light up as they are in person. So now I will show you some gameplay of this machine.